Hi, and welcome to cybrary.it. My name's Anthony, and I'm your local subject matter expert here for Network Plus. And today we're going to be combining two modules, modules 1.5 and 1.6, and we're going to be talking about common TCP and UDP ports, as well as explaining their associated networking protocols. So when we're trying to network computers together, there's more going on than just connecting two computers with a cable. When computers were invented, we didn't really have networking. Networking wasn't a thing. Computers were standalone machines which performed calculations. Networking didn't come until a bit later. Now, the first person who invented networking didn't just take some copper cable and plug in one machine to another. There has to be more to that. Computers need to know, how am I going to send this data? How am I going to package this data so the other side will understand what this is and be able to receive this data and put it back together in the right order? How will the other side know how to take this data and how to present it in a way that is able to be seen by humans? How will they be able to see this file? How do I authenticate myself? How do I make sure that this connection is going through? There's a lot that's going on when we're connecting to computers. It's more than just connecting via the wires. Now, when we're talking about computers and our modern protocols that we're using, a big topic and a big overview and a big concept we need to sort of start getting our head around is the TCP IP suite. Now, we've talked about the TCP IP model, but this is different. The TCP IP model is a way in comparison to the OSI model that we understand all the different layers of networking. The TCP IP suite is all of the different protocols and ports and TCP or UDP protocols that we use in order to make up the internet, in order to make up networking, in order for using our TCP IP suite, making it so that our computers can talk to another computer around the world. The TCP IP suite is all of the different protocols and everything all applied together so that we can make those connections. Now, the TCP IP suite, TCP/IP stand for individual topics. TCP stands for Transmission Control Protocol, and we've talked a little bit about TCP before. We've talked about TCP in the context of TCP versus UDP, and we'll get to that in a little bit. But TCP is a protocol for transmitting data which is verified delivery to endpoint of a one-to-one communication. So when we're sending data over a TCP connection, we're using a TCP protocol. We're sending a packet of data from one point to another point in a one-to-one correlation. So I am sending one point or one IP address this packet. And when it gets there, it's going to verify that it received that packet and it received it in the right order. That's what TCP does. Now, TCP encompasses several other protocols, which we'll also talk about, and these other protocols include things such as HTTP, SSH, HTTPS, different file transfer. So all of these different protocols either fall under TCP or UDP, another control protocol which we'll talk about in a little bit. But moving on with our TCP/IP suite, the other part of TCP/IP is the IP. Now, IP stands for Internet Protocol. An Internet Protocol is the protocol that allows us to address computers with IP addresses, allows us to route data around the world, and allows us to map logical IP addresses to a physical address. If it was just the TCP part, if it was just Transmission Control Protocol, then we may be able to send packets to computers that are on our same network. We may be able to send packets and deliver different messages to computers that we're directly connected to with a wire, but we would have to be talking between MAC addresses. And MAC addresses, as we've talked about before, are a layer 2 protocol, which means they're on our data link layer, which means they're not routable. We can't route packets around the world or across different networks that are directly for a MAC address. This is because our networks have different topologies. Our networks are set up in different ways. We'll talk later about ring topologies and bus topologies and mesh topologies, but essentially a topology is the way that we have our network set up to communicate, the way our network, quote unquote, looks. And different networks have different topologies and different ways they communicate. If we just try to communicate with layer 2 data link layer around the world, then it would be very unstandardized. It would be very difficult to control where our data went and how to get from point A to point B. You'd almost have to stretch a wire from your computer all the way to a switch that's in a completely different country if you're trying to get to that server. The IP part of TCP IP, the Internet Protocol, allows us to map those, allows us to take that third layer and actually route traffic, allows us to actually network traffic and move it around the world and take our physical addresses, map them to a logical IP address, and then use that IP address to deliver packets around the world. So we need both the TCP and the IP part of our TCP IP. And then IP is a routable protocol. So we can take an IP packet and put it in a router and route it around the world. It can traverse different networks. So that's our TCP IP suite. Now, let's take a look at our TCP IP suite as compared to our OSI model to get a little bit of a further look at this. Now, we're going to have to discuss ports and protocols to fully understand this, to fully understand our TCP IP suite. But we're going to start with our big overview, just so you guys get an idea of what we're trying to get our minds around, what we're trying to get our arms around, before we start breaking it into the subsections. So we're going to start from the overview and then break our way down. If necessary, I would almost recommend watching this series, watching 1.5/1.6 all the way through, trying to understand everything, and then after you get all the concepts, maybe watching it through one more time, or skimming through it one more time, or skimming through our notes one more time, just to say, okay, now that I'm understanding everything, let me just go through this one more time so I can really recapture it. That's the beauty of learning. That's the beauty of learning computers and learning networking, is after we learn the overview, then we learn how all the parts and pieces fit together, and then after we learn how all the parts and pieces work, when we take another look at our overview, we say, whoa, okay, now I understand. Now I'm understanding how all these parts and pieces fit together to form our TCP IP suite.